Welcome to a beginner's guide to C++ math functions. In this video, we will explore mathematical operations using the C++ cmath library. C++ provides a rich set of mathematical functions that allow us to perform complex calculations, including trigonometric, logarithmic, and power functions. Additionally, the cmath library provides useful mathematical constants such as pi, represented as m_pi. Here's a basic example to get started. First, include the IOStream and cmath libraries. Inside the main function, we can perform basic math operations. For instance, to calculate the square root of 25.0, we use the sqrt function and store the result in a double variable named result. Finally, the program outputs the result using std. Coot. Let's explore some common math operations available in C++. First, the function sqrtx calculates the square root of x. For example, sqrt 25.0 would result in 5.0. Next, pow xy raises x to the power of y. For instance, pow 2.0 3.0 would compute 2 to the power of 3, giving us 8.0. Then abs x returns the absolute value of x, so abs minus 7.5 would yield 7.5. Finally, round x rounds x to the nearest integer. Thus, round 3.7 would round up to 4.0. Now let's delve into trigonometric operations. The sin x function calculates the sine of x, where x is in radians. An example is sin m_pi/2, which equals 1.0, given that m_pi represents pi. Similarly, cos x calculates the cosine of x with x in radians, so cos 0.0 equals 1.0. Next, the tan x function computes the tangent of x, where x is in radians. Therefore, tan m_pi/4 is approximately equal to 1.0. Lastly, atin 2yx calculates the arctangent of y divided by x. Hence, atin 2 1.0 equals m_pi divided by 4. Here's a code snippet to illustrate trigonometric functions in action. Include the IOStream and cmath libraries. Define the main function. Convert degrees to radians by multiplying the degrees by m_pi and dividing by 180.0. We then calculate trigonometric values using sine and cosine functions. Finally, the program outputs the sine and cosine values of 45 degrees. Let's learn about logarithmic and exponential operations. The log x function calculates the natural logarithm of x, which is the logarithm base e. An example is log of exp 1.0, which equals 1.0. Next, the log 10x function calculates the common logarithm of x, which is the logarithm base 10. Therefore, log 10 100.0 equals 2.0. The expx function calculates e raised to the power of x, so exp 1.0 is approximately 2.71828. Lastly, the log 2x function calculates the binary logarithm of x, which is the logarithm base 2. Thus, log 2 8.0 equals 3.0. To use these functions, make sure to include the IOStream, cmath, and iomanip headers. The iomanip header is included to allow us to set precision for output. Inside the main function, set the precision for the output using std, fixed and std, set precision functions. This ensures that the output is formatted to 4 decimal places. Calculate the exponential value of e squared using the exp function and output it to the console. Additionally, compute and output the natural logarithm and base 10 logarithm of 100. Let's explore various rounding operations available in C++. First, the ceil x function rounds x up to the nearest integer. For example, ceil 3.1 results in 4.0. The floor x function rounds x down to the nearest integer, so floor 3.9 yields 3.0. Then the round x function rounds x to the nearest integer, so round 3.5 results in 4.0. Lastly, the trunc x function truncates the decimal part of x towards 0. Thus, trunc minus 3.8 gives us negative 3.0. To demonstrate these methods, include the iostream and cmath headers. Inside the main function, define a double variable named value, assign 3.75 to it. Apply each rounding method and print the results to the console. C++ provides several mathematical constants that can be used in our programs. m_pi represents pi, which is approximately 3.141592653589793238846. m_e represents Euler's number E, which is approximately 2.71828182845904523536. Then m_log2e represents log base 2 of E, which is approximately 1.442695040888963403736. Then m_log10e represents log base 10 of E, which is approximately 0.43429448190325182765. Finally, m_sqrt2 represents the square root of 2, which is approximately 1.41421356237309504880. Let's see how to use these constants in C++. Start by including the iostream, cmath, and iomanip headers. Set the precision for the output using std, fixed and std, set precision functions. This ensures that the output is formatted to 10 decimal places. Output the values of mathematical constants such as pi, e, and the square root of 2. Calculate the area of a circle using the constant pi and a given radius, then print the result to the console. C++ also offers some special mathematical functions for advanced calculations. The function hypot xy calculates the hypotenuse of a right-angled triangle, which is the square root of x squared plus y squared. The function fmod xy computes the floating point remainder of x divided by y. The functions fmax xy and fmin xy return the larger and smaller of two values, respectively. Lastly, the functions isnan x and isinf x check if x is not a number, often abbreviated as nan or infinity, respectively. Let's see a code snippet that uses these functions. Include the iostream and cmath headers. Calculate the hypotenuse of a triangle with sides a equals 3.0 and b equals 4.0 using the hypot function. Then compute the floating point remainder of 10.3 divided by 3.0 using the fmod function. Finally, find the maximum and minimum of -5.2 and 3.7 using the fmax and fmin functions, then output the results. Here's a summary of key takeaways about C++ math functions. We covered basic operations like square root, power, absolute value, and round. We also looked at trigonometric functions including sine, cosine, tangent, and aten2. Additionally, we explored logarithmic functions such as log, log10, exponential, and log2. We looked at rounding functions like ceiling, floor, round, and truncate. C++ also provides some important constants like m_pi, m_e, and m_sqrt2. Finally, we examined special functions like hypot, fmod, fmax, and fmin. Always include the cmath header to access these mathematical functions. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.